Okay. Hi, everyone.
Hello.
Hello. So I'm Sam.
And my name is Peter.
And today we're going to be talking about serverless technologies and serverless architectures. So we've built one of what we think is one of the world's first entirely serverless web platforms over the last year on top of AWS Lambda and a whole bunch of other web online cloud services. So we're going to tell you a little bit about that story today and what we've built and how we've built it. Myself and my colleagues also run the Sydney, Melbourne and London serverless meetups, and we've helped to form a network of meetups all over the world called Serverless Meetups. It's an amazing
It's a good name.
And in May, we also ran the world's first conference on serverless architectures, which was called Serverless Conf. And we ran that in Brooklyn in New York City. And that was a really big success. And we're about to run another one in London and in Tokyo. So it's all going a little bit mad at the moment. So today we're going to take you through some of the ideas that came out of Serverless Conf as well and some of the interesting conversations that happened.
Yep. Cool.
So very briefly about us. So I'm Sam. I'm the founder of an online learning platform called A Cloud Guru. So we train engineers on AWS via our on-demand video platform. So we've built our platform entirely serverless. In fact, we're a completely serverless company. So we don't run any servers at all. The only operating systems we have to manage are the ones running on these laptops, on our dev laptops. So we think that's pretty cool. Prior to A Cloud Guru, I worked for Microsoft both in Seattle and in Norway, in Oslo. I actually went to NDC Oslo back in 2008, which was pretty cool. And I was a developer on the Windows team in Seattle. So there I worked in the core file systems group, and I owned the disk defragmenter in Windows 7 and at the very end of Windows Vista SP1. I always get mixed reactions when I say that. I came onto the Windows Vista team just after they'd pretty much finished. I came in for Service Pack 1, and that was just after they made the decision to take the visualization away from defrag. So they made the decision, and I copped all the flack. People love those bars, those colored bars. I had the honor of getting to rewrite defrag from 0 lines of code for Windows 7, which was really fun, and I got to do it right.
Everybody still runs defrag, right?
Absolutely.
Yeah, cool.
Absolutely.
Cool. No?
Unless you have an SSD.
Shocked.
Don't listen to Hanselman about the SSD thing. You've got to defrag it, man. So yeah, I also worked on system restore, volume shrink, a whole bunch of stuff inside Windows. So when I talk about serverless today, I'm not anti-server. I actually spent most of my career building server software like Windows Server.
Cool.
And this is Pete.
So yeah, hi everybody once again. So my name is Peter, and I'm VP of Engineering at A Cloud Guru. I work together with Sam. My background is in computer science. I got my PhD in comp sci back in 2008, I think, a long time ago. I then worked for the Defense Science and Technology Organization. I worked for the United Nations in New York. And for the last 5 years, I worked for a consultancy in Melbourne. So I was a software team lead. And then I joined Sam, and we've been working on our platform ever since. And look, these days, my focus is on software architecture. I love web, but serverless. That's the thing that we really focus on these days, because it is very exciting.
Okay, so what is serverless?
Yeah.
And there's a lot of debate about this at the moment, and a lot of people some people don't like the term, some people don't care, some people call it Jeff. There's a whole movement to call it Jeff now because so many people don't like the term serverless. They're saying, well, it doesn't really matter, why don't we just call it Jeff? So
no, true story, seriously.
That's true. So the rise of the term serverless can really be attributed to the growing popularity of compute technologies like AWS Lambda that are often described as serverless. But I think if you look at the way people are actually building serverless systems, there's a lot more to it than just Lambda, right, or Azure functions. So my view is that serverless is a theme. It's an approach to building applications, and it's basically comprised of compute and patterns.
Yep.
So there are serverless compute technologies like Lambda, IBM OpenWhisk, Google Cloud Functions, WebTask.io, every major Azure Functions, every major cloud vendor has one now, as of a few months ago. And there's serverless architectural patterns. So these are patterns for crafting systems without traditional back-end servers. And the real power of going serverless comes from the integration with the other services. That's from our experience. Hooking, say, Lambda or Azure functions into native cloud services in AWS or Azure, and to third-party services to orchestrate rich and powerful event-driven pipelines to build up your systems. So this has been referred to by people way smarter than me as a serviceful approach, where cloud services are heavily leveraged, and serverless compute technologies are used as the last mile. The function execution technology is used as the last mile to weave all these different services together.
Cool. So what are these serverless compute technologies like Lambda, like Azure Functions, or Google Cloud Functions, or OpenWhisk? We say that they have two defining characteristics. First of all, there is a compute service which, given a bit of code, like a function, will execute it for you on demand. So take Lambda, for example. You can create a function, feed it to Lambda, and it will run your code for you. Secondly, we say that these services are event-driven. So code is run on demand in response to an event. So this event could be an HTTP request, right? Or it could be a new file pushed into an S3 bucket. And an event causes a function to invoke and respond automatically. And this function can do anything it wants, right? It can change the file, or it can carry out some external action, like, I don't know, taking a payment or something like that. And the cool thing is, function execution is stateless, right? And it's actually the magic sauce that makes everything very scalable, right? So the same function can be run thousands, if not millions of times in parallel.
Absolutely.
And we've heard of cases where Lambda scales to millions and millions of parallel invocations at the same time, which makes it so powerful.
One company we were talking to, Nordstrom in the US, doing 12,000 transactions per second in parallel through Lambda. That's not bad.
Yeah, for like $20 a month. Yeah.
Oh yeah, for $20 or $20.
Or $20 an hour. Sorry.
It's not bad for 12,000 transactions a second.
Yeah.
Okay, so how do we get here? This is the part of the presentation where I attempt to summarize the entire history of cloud computing in one PowerPoint slide. So
Sam promised to do this before in 2 minutes, so.
I said once that I was going to do this in 2 minutes, and then somebody tweeted me saying it was 4 minutes and 37 seconds. So I don't promise times anymore. So basically, the point of showing you this is to show give some context and show why we think serverless technologies are kind of the next leap in cloud computing, the next big enabler. So if you think about what's happened, a lot of devs like us don't like computer hardware, especially like me. It's cumbersome, it can break, and we've spent decades building layers of abstraction over layers of abstraction to get ourselves away from that hardware and to shield ourselves from the truth of what's actually running our code. So first we decided, hey, this is cool, let's chuck it in a data center somewhere, and someone else can be responsible for managing this system, making sure it's turned on, it's connected to the network. Awesome. As devs, we no longer need to get out of our chairs, right? Never needed to stand up and go and find the physical box. And in the data center, if you think about it, the hardware is the unit of scale. That if you need to scale, you add more hardware. And the physical hosting environment is now abstracted away to be someone else's concern. But provisioning that infrastructure is not fun. It wasn't fun. We had to talk to people. We had to make phone calls. We had to send emails.
Oh, God.
It was horrible. And it would take days, potentially, to get new hardware. And then in 2006, IaaS is really born in a big way with Amazon releasing EC2. And suddenly I can provision machines anywhere in the world using API calls. So from my command line, from my web browser. And this was heaven for me because AWS is basically just infrastructure as code, right? And same with Azure in many ways. So IaaS was born and we all cheered. And in IaaS, the operating system is now the unit of scale and the computing hardware is abstracted away to be someone else's concern. But something, I don't know about you guys, but IaaS always kind of bothered me. And I think it's because I still had to worry about that infrastructure. So it was still there. Yeah, like I couldn't find the physical box, but I still have to install the software on it. I have to worry about, is it patched? What if it gets owned? What if the SQL server runs out of disk space?
Hans-Solomon was saying the same thing today in the keynote. He
probably
copied your notes. Yeah.
So, what if it crashes, right? So you have to worry about that. So, and then PaaS came along. So you got these really compelling platform as a service offerings popping up like Heroku, App Harbor, cloud services in Azure. So what did PaaS offer that was new? So PaaS services really just take away all the headaches of configuring that system, patching it. PaaS is your way of basically saying, give me your app. So PaaS services say, give me your application's code, and we'll spin up a machine for you, and we'll run it, and we'll keep it running, and we'll keep it patched for you, which is nice, right? So with PaaS, your application is now the unit of scale. You scale at the application level rather than the operating system level, at least from your perspective. And that's cool. And now the configuration the operating system setup is abstracted away to be someone else's concern. So that's great. That's one less step that we have to perform as developers. But ultimately, there's still a dedicated VM there in most PaaS systems running my code to scale it. It still scales at the VM level. VMs have to be spun up and down. That takes time. And it happens in large steps. And in many systems, I can still remote into that VM.
Yeah, and it's costly as well.
It's costly. Yeah. It sits there running all the time, costing me money, even if it's not being used. So then serverless compute services have come along. So they really just take this and take it to the next level. So now I define a single function, a tiny piece of code with a single purpose, and I give this to the compute service. Not the whole application, but a function. So these functions have small, targeted responsibilities and minimal dependencies, and they're completely stateless. And as such, they're really fast to execute, and they scale effortlessly, and they can be massively parallelized, as Pete said. So from my perspective as the developer, there's no server sitting around anymore, waiting for requests, idling, and costing me money. And that's one of the big differences. I'm only paying for the time that my code executes and nothing more. The compute service is executing my functions only when my users actually want to do something. So with serverless, the function is now the unit of scale, and the language runtime is abstracted away to be someone else's concern. So a lot of people ask, how do containers fit into all this? Oops, is that moving? No, we're stuck. There we go. Yeah. Okay, so containers, everyone loves Docker, right? So containers are really a technology. They're not a managed service like these. So container technologies like Docker enable a lot of these awesome cloud services. And they're actually the underlying technologies that serverless compute services are built on top of, and a lot of the newer PaaS offerings as well. So it's a different level of granularity. So we'll talk briefly about Lambda. So Lambda is Amazon's serverless compute service. It's definitely leading the game right now. Came out a bit earlier than most of them. I think Lambda is groundbreaking, and I think it's as big a shift forward for cloud compute as S3 was for cloud storage. S3 being Amazon's equivalent of blob storage. And if you think about it, the two are really similar. So this came out, I won't take credit for this. I was talking to the Lambda team from AWS, and they gave me this corollary, and I thought it was a really good one. So Lambda is to compute what S3 is to storage. So S3 deals in objects for storage. So you provide an object, and S3 stores it. You don't know how, you don't know where, and you don't really care. There's no drives to concern yourself with. There's no such thing as disk space. Not enough space, too much unused space. These concepts don't exist. All of this is abstracted away. So you can't over-provision and you can't under-provision storage capacity in S3. There's no concept of that. It just is what you want it to be. So S3 stores and charges you for exactly what you give it, nothing more, nothing less. And now think about Lambda. So Lambda deals in functions for execution. You provide your function code, Lambda executes it on demand. You don't know where, you don't know how, and you don't care, right? Same thing. There's no virtual machines to concern yourself with. There's no such thing as server farm capacity. Too many idling servers, not enough servers to meet demand. These concepts don't exist. Scaling groups, they're not there. So all of this is abstracted away from you. You can't over-provision and you can't under-provision execution capacity in Lambda. So this is why I think Lambda is the next level for cloud compute, and it's as big a shift forward for compute as S3 was for storage.
Awesome. And look, before we go any further, we should say that the word serverless is a bit of a misnomer. There have been a lot of Twitter wars about the word serverless. Obviously, when you use a compute service like Lambda, or if you use another service or an API, of course, there is still a server running in the background, right? It isn't magic. as much as we'd want it to be. Of course, the difference is that servers are now hidden from us. They're not directly accessible to us. So there's no infrastructure for us to think about, and no way to tweak the underlying hardware or the operating system. And look, for example, if you use Lambda, AWS takes care of provisioning and management of the EC2 fleet of servers that actually run your code, right? They are responsible for providing that redundant, highly available compute infrastructure, including all the capacity provisioning and automated scaling. So you, as a developer, you don't need to think about it anymore, which is quite interesting. And so this frees you. Now you can focus on things relating to your specific problem. And you can move quicker and, overtake your competition. So look, there are these serverless technologies that are now kind of coming out. And developers are taking these technologies and building entirely serverless platforms and applications at scale. And look, this is the patent spot. You can see right now some serverless architectures. And in these new architectures, traditional servers are replaced by an array of awesome cloud functions that act as discrete single-purpose services. So for example, right there you see compute as a backend architecture. And so we have a client, right? We have an API gateway, which creates basically a RESTful API. It's a service that you can create in AWS. And then you have a number of Lambda functions connected to the API gateway. So when a request reaches the API gateway, that invokes a Lambda function which processes that request, does something exciting, and then there you have it. So there are no expensive web servers sitting around, waiting for your requests. Everything is kind of done on demand when a request comes in. So another pattern we refer to as compute as glue is a way of kind of forming very powerful pipelines between different services, right? So in that diagram, you see a search service, you see a notification service, an S3 bucket, all kinds of services. And so you can use cloud functions like Lambda to glue these services together and to marshal data between the services, to coordinate actions. So you can now build really powerful pipelines with just a little bit of code. And so the movement towards serverless is actually blowing up right now. It is very exciting. And all the major players, all the major cloud vendors are heavily investing in this space. So like Sam said, Amazon started with Lambda. Google has cloud functions. IBM has whisk. Microsoft has Azure functions. And look, even the press, like the mainstream press, is taking an interest. We saw this article a couple of months ago from the tech editor of New York Times, saying that
Talking about
this
serverless
is
technologies.
saying that this is something that's growing. So yeah, it's not a niche thing anymore, and it will only get bigger.
Cool.
And like Sam said, in May, we founded and ran the world's first conference on serverless technologies in Brooklyn, New York. And we had some really amazing talent come and talk to everybody who attended the conference. So we had Tim Wagner, the general manager of Lambda, give a keynote. We had chief architects from IBM whisk. We had the Azure Functions team. We had banks. We had people from Firebase and Google, engineers who worked on PaaS and Facebook and Spotify and Docker and iRobot. And so everybody seems to be getting on board with this.
And we're actually putting all the talks from Serverless Conf are going live tomorrow online for free. So if you watch our Twitter, you'll see it. There's some really interesting ones, like how Spotify are moving their entire data analytics platform from on-prem to Google Cloud platform while it's moving without turning it off. It's called changing the tires on a moving car. It's really quite interesting.
Yeah, so there are a lot of awesome talks. Yeah, I encourage everybody to have a look. So yeah, you can see that the level of investment going into these serverless technologies is actually quite large. Yeah. And yeah, it's very exciting. So yeah, it will be published hopefully tomorrow, and you guys can see it. And look, a lot of people ask, isn't this just microservices? right? Isn't this, yeah. Well, no, but kind of. And we say that the two are related. So microservices and serverless architectures are spiritual descendants of service-oriented architectures. And look, you can implement a microservices approach using serverless technologies, but you don't have to, right? So developers tend to think of microservices as these small, standalone, fully independent services built around a particular business purpose, right? And depending on how you design the system, every compute function could act as that standalone service with its own API and data storage. You can do it. Or you could compose a microservice out of a few cloud functions. Or you could build a distributed monolith if you wanted to. I wouldn't recommend it, but you could, right? Or we use cloud functions as small nano services that just do one or two little things. So they are even smaller than microservices. So you have this flexibility, and you have these new emerging architectures that we will talk about that give you many more freedoms and flexibility with what you can do for your systems.
We've been writing a book, mostly Pete's been writing a book on serverless architectures on AWS, and Pete's been going around talking to people all over the world who are building apps and platforms with serverless technologies. It's been really interesting to compile all the patterns together and see how people are using this, because there isn't really any standards yet or standard approaches.
Yeah,
so
this area is so new. It still blows my mind when I talk to companies and I see them using this in some way that we had never thought of.
Never imagined.
Never imagined. So it is very interesting. This area is emerging, so I encourage everybody to get on board and contribute, because you guys are the pioneers.
Okay, so I want to tell you very briefly about our story and what we've built and kind of how we got here. So last year we put some courses on udemy.com, teaching people about AWS and helping them with their certifications. The whole thing went a little bit insane very, very quickly. And after a while, after a few months, we decided, well, let's build our own training platform. Let's make training fun, and let's try and build the world's biggest and best online community of AWS engineers. So that's what we've been doing for the past year. Interactive discussions, gamification, lots of stuff to make training really fun and interesting. So we launched the platform only 10 months ago. Since then, we've scaled to over 60,000 customers now, engineers globally that we've trained across about 120 countries or more. At any given time, there are thousands of people on our platform using it simultaneously, doing video courses, quizzes, interacting with each other via discussion forums. And our system is completely push-based and event-driven. So there's not a single piece of code in our entire platform that polls or periodically requests something. Everything is push-based from browser to browser at both ends. So that's kind of cool. So not sure why we need this slide. It's probably pretty obvious at this point we don't run any servers. And in fact, one of the coolest things is our hosting bill is almost non-existent. Considering the scale of our business now, we pay hundreds of dollars a month in hosting in total, because we've never paid for Lambda. The free tier is so generous. 3 million executions a month?
Yeah.
No, sorry, oh God, I can't even remember now. I've said it so many times.
Yeah.
1 million.
1 million, yeah.
It's so generous that we've never had to pay for it. So basically, the only thing we pay for really is bandwidth in and out.
Just don't tell Amazon.
So bandwidth out of the cloud.
They'll charge us.
We don't tell Amazon. And to give you an idea of what we've built, I mean, we've got users watch videos in our course viewer. They do quizzes, practice exams. It's responsive. It scales down for smartphones and tablets. We've got our discussion forums. It's kind of Stack Overflow style. People can ask questions, answer questions, vote each other's answers up and down, comments. People build reputation. So you can see it's not a toy, right? This isn't just some experimental toy. What could we build on top of Lambda? This is a fully fledged, rich web application running in production, supporting thousands of users simultaneously 24 hours a day. And if it goes down, it costs us a lot of money. So why did we do this? Because this is probably a little bit insane to build it this way, right? So the main driver for us early on was number one was rapid time to market. So at the start, this was just me. And I took 3 weeks off work to try and build a learning management system in 3 weeks. So I was constrained. And so there wasn't some grand vision to build this thing serverless. It was just out of necessity. I thought, well, hey, if I build this thing on top of Firebase, I can write to the database directly, I can cut out some layers, I could probably fill in the gaps with Web Task IO. This was before Lambda was available for API Gateway. And I really truly believe if we'd taken a traditional web server approach, I never would have got the business off the ground because I just could not have built the system that we built in the 3 weeks that I had. We needed to scale fast and effortlessly because by the time we launched this, we already had 10,000 customers on Udemy. So we knew when we launched it, it wasn't going to be a typical slow triple startup. It was going to be people coming on board quickly. So we needed to know that whatever we built would scale quickly and without a lot of overhead or monitoring because it was just me at the time, me and my business partner. We're a sale-driven business, so we have large spikes during Black Friday and sale periods, so we needed to be able to scale up and down quickly without a lot of cost. And last of all, we wanted to offer a disruptive cost model. And I think this is one of the big differentiators about Lambda or Azure Functions, for example. So our business model is disrupting the traditional training model. So instead of paying thousands of dollars for in-person training, or even just ongoing monthly fees for other online course platforms, like $50 a month or $100 a month.
We won't mention any names?
No names.
No names, yep.
Our customers pay $29 for a course. They pay it once, it's a one-time purchase, and they have lifetime access forever to that course. And we literally couldn't do that without Lambda and AWS. So Lambda enables that because we only pay for the time that our code executes. So we have no web servers sitting around, no load balancers. CloudFront and S3 enable that because we only pay to deliver videos when someone actually requests it. So when someone watches a video, we don't have expensive media servers sitting around to encode it. We use Elastic Transcoder. That's also on demand. So think about what that actually means. If you step away from that, that means that we only pay as a business when a customer actually uses our system and actually wants to do something of value to them. So we only pay for a customer when they take a course, and customers take a course once. Nobody watches the same course 10 times unless they're mad. So we don't need to charge ongoing fees. On average, it costs us about 12 cents US to deliver a course. That's our total cost of delivery. That's if they do the whole course. So this has literally enabled our business model and fueled the growth of our business.
Yep. So look, as we kind of built our platform and began exploring and understanding serverless technologies and architectures, had our conference, began talking to other companies that are working in the space, we kind of really tried to develop our understanding of serverless and serverless architectures. And so we developed a number of principles that we tend to follow when we architect serverless applications ourselves. And so we have covered these in a lot of detail in the book and given examples. Actually, yeah, this is going to be taught at Columbia University next semester, which is very cool. So
pretty awesome.
We're looking forward to it. So we just want to quickly kind of describe what these principles are and give you, I guess, a quick illustration with how we applied these principles in practice. So of course, principle number 1, very obvious, very important. Use a compute service like Lambda to execute your code on demand.
Or Azure Functions.
Or Azure Functions, of course. Yeah, don't run a server. Don't be silly. Just don't do it. Your, I guess, goal is usually to solve an interesting problem. It's not to, patch Apache or something, usually. So, and look, you can write a function to carry out almost any task, right? You can read and write to a data source. You can call out to another function. You can perform a calculation. It's just code, right? And of course, look, we are realistic. There might be scenarios where you do need a server, right? It does happen, especially if you need to run legacy applications or third-party applications. But these cases should be, well, hopefully will be far and few in between, so try to minimize your usage of a server. Don't manage one. And principle number 2, so try to write your functions with the single purpose, I guess, a single responsibility principle in mind, right? Your functions should do one thing and one thing only. We know that as software engineers, if you follow the single responsibility principle, you'll create, I guess, functions or code that is more testable. It will be more robust. It will have fewer side effects. It'll be easier to understand. And by composing and combining these services and functions together in a loose orchestration, you will be able to create complex back-end systems that are still understandable and easy to manage. And look, a granular function with a well-defined interface will also be a lot more reusable. You'll be able to reuse it a lot more often in your serverless architecture. And as we said before, code written for Lambda should be written in a stateless style. You must not assume that resources will survive beyond the immediate invocation of a function. It is actually not entirely true because containers are reused, so you can actually find files from previous invocations on the file system if you go and explore the container, but
you can't assume it.
You cannot assume it, yeah. So Lambda and Azure Functions and other providers, they can create and give you a brand new container to execute your function at any time.
Yeah.
And look, it's often very hard to know where the granularity of a function actually is. If you make functions too granular, you'll have too many functions to manage, and it'll become a bit of a nightmare. If you ignore granularity, you will create mini monoliths as well. So it takes a bit of judgment and a bit of experience. And I guess we have a few.
We have some examples.
We have some examples
from how we've done it.
Yeah.
But everyone's going to do it differently.
Absolutely, absolutely. So we, for example, have a function that allows our users to submit questions and comments on our forum.
Yeah. So we try to make these basic, kind of like commands in a command pattern.
Yeah.
Submit a question, submit an answer. We've got.
Yeah, so we allow our users to vote in our forums and update their reputation scores.
So we'll have one for vote up, we'll have one for vote down.
Yep.
GuruBot, he's my favorite. So Lambda and function technologies are great for building bots and Slack bots. So we have a little guy called GuruBot. He's my favorite little Lambda function. And GuruBot works out what our instructors on our platform have earned. So they can call him via Slack and they say, how much revenue did I earn today? Or how much revenue did I earn this month?
Yeah.
So GuruBot can be run on demand via HTTP, but GuruBot also gets executed on a schedule, once a day, once a month, and produces reports.
Yeah, our instructors and lecturers love GuruBot. Yeah, he's awesome. We have a function that takes payment. So when a new user comes to our platform and buys a course, this is the function that will process, payment. Yep.
And requesting protected files. I mean, if you think about what we're doing, serverless, we're selling videos, but videos need to be distributed via a CDN, but they need to be private. They can't be public because you have to pay for them. So we have a Lambda function that generates signed URLs for the CloudFront CDN. So a user requests it, we look, we see, do you have access? Have you bought this course? Yes, you have. Okay, we sign a URL. That signature, that encrypted signature lasts for a certain amount of time, like 3 hours. We return that, and then they're able to request that URL, embed that straight into a HTML5 video tag in their browser, and watch the video.
Yep. It's awesome. Look, as you begin to work on serverless applications, you will have to quite likely create workflows, right? You'll have to process your data in some way. So when you do that, try to design these workflows in a push-based, event-driven pipelines, I guess. So these pipelines, when they are event-driven, they become really powerful. They will allow you to extend your architecture really simply, and they look like magic when they work. So an event-driven pipeline is one that, I guess, kicks off thanks to an event, and then continues to propagate without additional user input. So one event basically triggers another event in a pipeline. And look, building systems in an event-driven, push-based approach will often reduce cost and complexity. This is at least what we have found. And it will actually make the overall user experience a lot smoother, right? So because you won't have to poll, it will be cheaper, and users will get whatever they need on demand. And yeah, we'll show examples as well. So yeah, here's a simple example.
Cool. So yeah, we use a NoSQL database called Firebase for our user-facing database. It's essentially like a materialized view in CQRS. So Firebase is a real-time streaming database that works over WebSockets. So changes that are made to the database are synced immediately out to all connected clients. So out to all of the connected clients' web browsers via WebSockets. So there's no polling. just the goodness of sockets. And it works across a range of devices and mobile devices. So that's great. So in this example, a user will come, Peter comes to our site and he wants to submit a comment on our forums. That'll go to API Gateway, which will get routed to Lambda. A Lambda function will do some validation and some checks. It might do some other things that are not on this diagram, like updating a search index. And it'll also push the comment to Firebase. That push to Firebase will cause an immediate push out to all our connected clients, which will receive that update automatically. So anyone who's looking at that page will now see the new comment without having to refresh and without having to poll. So then we have this example.
We could actually simplify that previous architecture a little bit and actually have one user write straight to Firebase from their web browser, right? It's possible, and it is actually encouraged. And you might say, oh my God, what a nightmare, writing
to the database from your user's web browser.
Yeah, but it does actually work, and you should apply this pattern in a number of
if you know what you're going to
cases.
write is going to be, if it's an all or nothing proposition, you're not orchestrating multiple calls. If you're doing one and it either works or it fails, then it's fine.
Yeah, and this will absolutely reduce the amount of layers you need to have in your system, which is a big benefit. So here's another example. We have a transcoding pipeline. So when a lecturer creates a new video, they upload this video via our interface, and then our system creates a number of different versions of this video. So we re-encode those videos to 1080p, 720p, 480p, for 80p, HLS, WebM, MPEG-Dash, and a number of different formats.
We even and generate thumbnails every 30 seconds.
Yep. Absolutely. So the process is rather simple. We have our users upload files directly to an S3 bucket. That automatically kicks off a Lambda function. A Lambda function goes, hey, there's a new file in an S3 bucket. Then it creates a job for the Elastic Transcoder, which is the service that creates those other additional versions of the file. So Elastic Transcoder creates those files and puts them into another bucket. That, in turn, kicks off yet another Lambda function. That, in turn, pushes a message onto an SNS topic. And then we, as you can see in this diagram, we apply the fan-out pattern. And so the fan-out pattern basically invokes a number of Lambda functions in parallel. One of those Lambda functions picks up that message and goes, hey, there's a new transcoded video in the bucket. It then goes and writes to Firebase to say there is a new video that our students can now view. And because, like Sam said, all of our students, everybody who's using the website is connected via WebSockets to Firebase, they get that update instantaneously in near real time. So as a user experience, a lecturer uploads a file to S3, and then a few minutes later or half an hour later, our users, students see a new file pop up automatically in their interface. So there's no need for them to poll, to refresh. Everything is push-based and on demand. So it's very powerful.
But look, what's really interesting, if you look at that pipeline, look how little code there is. I mean, to build this entire video transcoding pipeline, it's a couple of hundred lines of code at most. There's 2 Lambda functions, really. I mean, there are a couple other extra ones that hang off for fun. But to do that video transcoding, it's almost no code. And you only pay when something actually runs through it. So very little cost.
And we are using those Lambda functions to glue all of those other services together to create something quite powerful.
OK, so this is the controversial one.
Oh, yes.
This is against everything you've
People are going to work
ever
out.
been told. And this works if you're building web-based systems. So create thicker, more powerful front ends is what we recommend. So if you think about it, your traditional 3-tier approach to software architecture, you've got your browser, your presentation tier, you've got your web server, which is your logic tier, and you've got your database, which is your data tier, roughly anyway. So that layering is nice. We've been told that's really important. That keeps separation of concerns, and it's great. But it becomes really tedious to maintain and to improve and to add new features. And it's actually really exacerbated in a world of single-page applications. I don't know if any of you guys have felt this way, but with a single-page app, you've now got your whole MVC framework in the browser with your views, controllers, services. These services then have to talk over the wire to your server with some kind of communication contract, some kind of DTO contract that you've defined, you've got to maintain. You've then got to unpack that on the other side, validate it, apply it to some model. You've got to do the same get the data from the database, apply it to some model, and then transform everything, apply your business logic. That's a lot of work. And if you want to add a new feature to your product, you've got to touch every layer through that stack. And I'm sure you guys have. We've worked on systems that had multiple other services in this layering as well. We had one to add a button to a UI. We had to touch 15 different layers every single time.
Yep, all the managers and all the proxies.
Because the web server went to a WCF service, which went to another service, and then which went to a database. So it's painful, right? And it slows things down. Lots of layers.
And just because we've done it this way doesn't mean that it is not incredibly stupid.
Yes,
as well.
exactly. So with the explosion of all these cloud-based web services, and now you've got all these new security mechanisms, CORS, JWTs, JSON Web Tokens, SAML. So something new becomes possible now. Your front-end app can talk directly to a range of cloud-enabled services. So that's both small cloud functions that you've built, but also a whole bunch of third-party services. Like we just talked about Firebase. That is a web-enabled database. Your front ends can write directly to it and read directly from it. So now it's actually possible in many cases to remove the middleman. You can completely break apart that monolithic web server and replace pieces of it with external cloud services that already exist. And then anything you need to write custom, you can just use small cloud functions running in the cloud on demand. So the client app is now a lot smarter. And this new model means that now the majority of your data transformation and business logic code actually sits in the front end. You have some of it in Lambda or Azure Functions, but a lot of it's in the front end. And so most of your code is in one single code base. Makes it a lot easier to dev locally, to test, to debug. You're not jumping between different debuggers and watching DTOs go across the wire. So it can really cut the layering down to look something like this. You want to add a new feature, you just add it to your front end. So there are many cases in our system where we add a new feature and it's front end only. It's front end code only. Just save to Firebase, read from Firebase. If we need to do something in the cloud, add a tiny Lambda function to maybe just do the last bit. Something that needs to be protected. You might need to load some private data from other users to perform some action like send an email that you can't trust to load in your end user's browser.
Yep.
And then the very last one, it's pretty obvious at this point, but use third-party services. There are companies who dedicate 100% of their resources to doing very specific things and doing them really well. So we use like Auth0 for authentication and login. Like Auth0 actually render the login box on our website and the sign-up forms. We don't have to worry about that. If we wanted to enable Twitter login, we just tick a button in Auth0's dashboard, and we've got Twitter login on our website. So it's some really cool stuff you can do. We're onboarding some really large corporates at the moment, and they come to us and they say, can you do SSO with our ADFS installation? And we say, yep, Auth0's done it. It's really, really simple.
I used to spend weeks in my previous job hooking up ADFS to clients, and it would take weeks, right? But now we can actually do it.
Auth0 has it all out of the box.
It's amazing.
So intercom for customer support and messaging, there's heaps of them. There's so many great services out there. So really try and outsource everything that's not your core product, right? Focus on building what you do, making what you do well. Maybe we'll jump over. We've only got 15 minutes.
15?
Right? Yeah, we've got 15 minutes. Cool. So we're going to talk very briefly about Serverless Conf. We'll give a bit of a roundup of what different people talked about and what other people in the industry are doing around serverless, because we found it quite interesting. We had this idea, let's run a conference. How hard could it be to run a conference on the other side of the world?
We've never done it.
Yeah, it's not that easy. We didn't know if anyone was going to turn up, so we booked this rock concert venue in Brooklyn for 200. It would hold 250 people. That was in January when no one was really talking about serverless. We didn't realize that in the next 3 months, interest in serverless was going to explode. Azure Functions was going to come out. So we ended up selling out with a massive wait list, and we had every cloud vendor came along and both attended and sponsored the conference. So Amazon, Microsoft, IBM, Google, and then a lot of progressive organizations like Capital One, Bustle.io, Nordstrom, really interesting people. And look, we kicked off with a keynote by Tim Wagner, who, as I said, is the general manager of Lambda at AWS. And Tim is actually the guy who came up with the idea for Lambda. And he pitched it to Andy Jassy, who's the CEO.
And look, Tim is actually an ex-Microsoft guy from the Visual Studio division of Microsoft. And it just shows you the danger of letting your good talent go. You never know what might happen.
Especially in a place like Seattle.
Absolutely. Yeah. And so yeah, Tim opened the event with a bang, literally. He destroyed a bunch of fake servers with a baseball bat.
So we've
if you can show the video,
we've got a video here.
It was unexpected. And he just comes out on stage, gets out the baseball bat, and we're like, whoa,
awesome.
what's he going to do?
We didn't know he was going to do it either, so it was fun.
We had no idea. And I just felt bad for the next speaker who had to follow Tim after that because
it was IBM.
It was IBM, those poor guys.
Cool.
And so Tim basically spoke about Lambda, what it was. He said that it was the world's largest bin packing problem. So the AWS infrastructure allocates space for containers to run. And it does it in the most efficient way that it can. And he also announced a new open source project called Flourish. Unfortunately, the details are a bit vague. We still don't know exactly how it will work.
It's supposed to be some way of defining serverless systems, both the API gateway, the API and the functions, but some open format.
That's right, but we're still waiting for details, so we don't know as yet, but it looks like it will overlap or compete with the serverless framework, if you guys have heard of it.
Not if you ask Amazon. They say it won't.
We don't know.
We don't know what it is.
We don't know, yeah.
Okay, cool. Then we had Patrick Dubois. So Patrick Dubois is the founder of DevOps Days. He's the guy who coined the term DevOps. Really insightful, smart guy. And he's doing everything serverless these days in his new company. I found his talk really insightful. So it was called From Serverless to Serviceful. I talked a little about Serviceful earlier. So he talked about how in a serverless world, we're relying on all these third-party services now. And where we might have had back-end servers in the past, we now call out to all these services. So we've got back-end services like these. These are some of the services that they're using at his company, Small Town Heroes. IT support services, office services, front-end services, mobile services. We're heavily reliant on so many different companies now. So then he went into a whole explanation of promise theory, which was really interesting. And you can go look at this talk. He'll do it a lot more justice than I will. But he's talking about all the promises that agents in the system make to each other and the contracts between them and the commitments that they have to meet to ensure reliability of these systems. And then he touched on some real-world examples of what happened when things go wrong. So this is, GitHub. GitHub's broken, everybody take the day off. I mean, our deployment system is all based off GitHub. So if GitHub goes down, it makes it very hard for us to deploy.
We are taking a day off, right?
Yes.
If it happens, good.
Yes,
right. Just making sure. Yeah. It's on camera now. Yeah.
Then there's giving up control to third parties. So in this example, Amazon disabled email sending due to too many email bounces back. So this is SES. And if you look at the email, the message there from Amazon, it's a 24-hour turnaround process for your appeal. So you're at the mercy of Amazon to restore service. There's really nothing you can do at that point. And he talked about how you have to understand the limits and the peculiarities of the services that you use. So here you can see AWS basically admitting that container reuse in Lambda is completely non-deterministic. You cannot accurately predict when or how often a container will be reused. And that's a big deal when you're looking at latencies, because if a new container is spun up to serve a Lambda function, there's a significant latency compared to if it's reusing a container. So what this means is it's impossible for you to give latency or performance guarantees to your clients because Amazon can't give it to you.
Yeah.
And he talked about how the collaboration between dev and ops is now extended to third parties. So there was a lot of controversy before this conference about no-ops. I don't know if anyone saw it on Twitter. It was an article that was published on the News Stack around the same time as Serverless Conf, and we were quoted in it.
Unfortunately, yeah.
Even though we didn't.
In a different context, though.
In a different context, but it proclaimed the era of no-ops. Hello, everything's serverless, there's no more operations, it's magic.
That didn't go well.
So let's be clear, there are still operations in serverless systems. You still have to run operations. You can't outsource just magically all of your responsibilities to someone else. But I think the responsibilities are shifting. So developers of the serverless system now take on more responsibility. A lot of it's done through code. But you're also using other people's operations teams. So Firebase's ops team is really, we should consider it part of our ops team. Amazon's ops team should be part of our ops team. because if something goes wrong there, we need to deal with them to make sure that it gets fixed for our customers or that we find a workaround.
That's right. Yep.
So then Charity Majors came to speak. So Charity is an engineering lead from Facebook. She worked on PaaS. I don't know if you guys know PaaS, but it was kind of a big first kind of serverless backend as a service technology that Facebook bought and then shut down.
Yeah.
To quite some controversy.
Whoops.
Because PaaS is, the whole point of PaaS was don't use anything else, just build everything on PaaS. Your back end, your front end, everything.
Yeah.
We'll do it all for you. Oh, by the way, we shut it down.
Those poor devs. Yeah.
So she worked on that. She worked on Hound, and she worked on Second Life, the game Second Life. So her talk got a lot of attention, and her blog post got a lot of attention. So Charity was a bit upset, or maybe didn't like the no-ops article that came out, being an operations person herself. So in the glorious future, we will be serverless and there will be no ops. And you can see what Charity thought of that. So Charity ran the operations team at PaaS. So she had first-hand experience building a back-end as a service platform when many customers of that platform had an expectation of just kind of outsourcing ops to PaaS, just like, you guys deal with it, right? If something goes wrong, PaaS will fix it. So for example, scaling. She was saying customers would kind of abdicate responsibility for performance. Just expect PaaS to scale magically. You know, like it says there, services are not magical pixie dust. So even if you outsource your back end, you can't use crappy architectures, right? You still have to consider the performance implications of your data queries. You know, if you're smashing the servers with writes or you're writing poor queries, you know, we use Firebase. We have to understand how Firebase's querying system works to get the best performance out of it. So you still have to think things through. Design still matters. So Rainbow Dash is a software engineer, and she's going to use hosted services. She's going to pay them to do all of the thinking for her, right? But Rainbow Dash is a little confused because why are my users complaining? Everything was working yesterday. I didn't change anything. What is query? What is index? So Rainbow Dash resorts to whiskey. So her major point was even if you outsource something, you're still responsible for the results. It's your business. And it's not good enough to say, oh, but Lambda went down. Your customers don't care, right? You should have architected for that scenario. The tools are there. You need to think about these things. So labor can be outsourced, but caring can't. Nobody cares about your product as much as you do. So make sure you think holistically about the system. Because think about what we're doing here. We're connecting all of these different systems together to build something unique for our products. Everyone else is managing a link in that chain, and they only care about that link. You have to manage that end-to-end flow and make sure it works. And if some link dies, that you've got some workaround or some way to recover.
Yeah. And I think that's an important message because we say that Lambda is scalable, it's amazing, and it is. But if you don't get the architecture right, then Lambda won't help you.
Yeah, absolutely. Well, we've only got a few minutes left, so we'll touch briefly on WebTask, because I think WebTask is really cool. So this is Tomasz Janjuk. He works at Auth0, and he's the creator of WebTask. He's actually ex-Microsoft. He built the Node.js implementation in Azure in web jobs. He got laid off in a big Microsoft layoff and ended up going to Auth0 and building WebTask. So again, don't lay people off in Seattle. So it's architected a little differently from all the other function as a service providers. So it was built to scratch an itch at Auth0 to run user-created JavaScript rules. Anytime anyone wants to log in to an Auth0 system, you can have JavaScript rules run on every login and perform some kind of processing. We use this ourselves. And this is the reason I got interested in serverless, because I built the first version of our platform on WebTask, because Lambda didn't have API gateway at that point. So they wanted to easily allow customers to run these rules every time a user logs in. And they needed to run them on demand in a scalable, sandboxed manner. So they essentially wanted to offer webhooks. But webhooks are annoying, right? Because you expect your customers to stand up servers and execute incoming webhook calls. And how can you be sure that your customers will do that in a scalable manner? Are your customers going to introduce bottlenecks? Are they going to make sure that the calls to these webhooks scale? So Auth0 built WebTask. It's basically a webhook with a server included. That's the way they look at it. So you write some JavaScript code, you give it to WebTask, and WebTask exposes it via HTTP. It's actually a really beautiful developer experience. On the command line, you write WebTask, you give it your JavaScript file, and it just returns to you on the command line a URL. That's your URL to execute your function. So it's really as simple as that. We've only got a couple of minutes left. I think what we might do is just move to the last one, which was OpenWhisk.
Yep, OpenWhisk. So IBM is getting into the serverless space in a big way. And so the IBM Bluemix OpenWhisk team, who works on serverless at IBM, came to talk. And so, OpenWhisk is IBM's serverless system. And it's a little bit different from the other ones. And it is aimed at being entirely open. It's open source. You can grab it on GitHub. You can see what it does. And you can actually run the whole thing on your own infrastructure, which is kind of interesting.
You can run your serverless compute service
on your own
server.
If you're keen, yeah. It's
yes.
Or you can run it in IBM's cloud, of course. Yeah. So it has an open interface for event providers. So you can write your own event provider for the system, your own event source for functions.
That's pretty cool. So if you want to run an event on every GitHub check-in, you can write an event provider for GitHub check-ins.
Absolutely. So so you can actually even share your functions. So I think they call them actions. That's right.
Yes.
And they actually they're starting up a marketplace so where people can develop functions and then sell them to others.
And share them. And they even have this, IBM had probably the most beautiful user interface
Oh, it was amazing.
Out of all of them, which blew everybody away. IBM with a beautiful user interface. And you can compose these functions together and you can build these pipelines visually and chain all the functions together and actually bring in functions from the public marketplace, drop them in your pipeline.
It's beautiful,
amazing.
Yeah. And the other thing is, those functions or actions can be written in Swift. So this is Apple's Swift, or with Node.js, JavaScript, or you can actually even execute your own custom Docker containers, which is
their pitch there to iOS developers is don't go and learn another language. If you want to run some stuff in the cloud, just give us some Swift code and we'll run it for you.
Yeah.
And they even have an SDK that you can execute from iOS. So
absolutely.
cool.
So it's very alternative and very, very interesting.
Yeah.
Yep. We can probably go on to the next slide.
Cool.
Awesome. So look, how can you get started? You can check out our website. We have a course on Lambda. It's actually getting a refresh today or tomorrow or sometime soon. And we are going to post our serverless meetup talks as well. So we run 2 serverless meetups, one in Melbourne, one in Sydney. So please come along to our meetups. Follow our Twitter at @acloudguru, and we are going to announce serverless.conf videos hopefully within a day. Tomorrow, yes. So you'll be able to.
Some really cool videos there.
Yep, yeah, absolutely. And finally, you can check out our book if you'd like. You can actually go to this URL that you have there, or go to book.acloud.guru. Check out the book. Let us know what you think.
Cool. So look, that's it. It's a brave new world, but it's a lot of fun if you're a dev. Serverless technologies let you focus almost exclusively actually on developing your unique idea and not losing sleep every night about whether your SQL servers run out of disk space. So I really encourage you to give it a go, and thanks for coming to listen to us today. And if you have any questions, just come up afterwards.
Yep. Perfect.